Hello, this is Jeffrey Chang, and the topic we're going to discuss today is polynomials. Here's the learning objectives. In this section, you will learn to identify the degree and leading coefficient of the polynomials, add and subtract polynomials, multiply polynomials, use FOIL to multiply binomials, and also perform operations with polynomials of zero variables. So let's start off from identifying the degree and leading coefficient of polynomials. A polynomial is a sum of or difference of terms, each consisting of a variable raised to non-negative integer power, a number multiplied by a variable raised to x1, such as 384 pi, is known as a coefficient. Coefficients can be positive, negative, or zero, and can be whole numbers, decimals, or fractions. Each product aix to the power of I, such as 384 pi times w, where w is a variable, is a term of a polynomial. If the term does not contain a variable, it's called constant. So a polynomial containing only one term, such as 5x to the fourth power, is called monomial. A polynomial containing two terms, such as 2x minus 9, is called binomial. And a polynomial containing three terms, such as negative 3x to the power of 2 plus 8x minus 7, is called trinomial. We can find the degree of a polynomial by identifying the highest power of the variable that occurs in the polynomial. The term with the highest degree is called the leading term, because it's usually written first. The coefficient of the leading term is called the leading coefficient. When a polynomial is written so that the powers are descending, we say that it's in standard form. So you can look at here. Here's a leading coefficient, where the degree is this is the highest degree. And here's the leading term. The whole thing is called the leading term. Yeah. So here's the role of polynomials. A polynomial is an expression that can be written in this form, like this, where n keep descending until it reaches 0. Each real number ai is called a coefficient. The number a0 that is not multiplied by a variable is called a constant. Each product aix to the power of I is a term of polynomial. The highest power of a variable that occurs in the polynomial is called degree of a polynomial. The leading term is the term with the highest power, and its coefficient is called a leading coefficient. Next, adding and subtracting polynomials. We can add and subtract polynomials by combining like terms, which are terms that contain the same variable raised to the same exponents. For example, 5x squared and negative x squared are like terms, and they can be added to get 3x squared. But 3x and 3x squared are not like terms, since it's like x and x squared, and therefore they cannot be added. Next, we got multiplying polynomials. Multiplying polynomials is a bit more challenging than adding and subtracting polynomials, since we must use the distributive property of multiplying each term in the first polynomial by each term in the second polynomial. We then combine like terms. We can also use shortcut called FOIL method when multiplying binomials. Certain special products follows pattern that we can memorize and use instead of multiplying the polynomials by hand each time. We will look at a variety of ways to multiply polynomials. Multiplying polynomials using the distributive property. To multiply a number by a polynomial, we use the distributive property. The number must be distributed to each term of the polynomial. We can distribute the 2 and 2x 2 bracket x plus 7 parentheses to obtain the equivalent expression 2x plus 14. When multiplying polynomials, the distributive property allows us to multiply each term of the first polynomial by each term of the second. We then add the product to get the combined like terms to simplify, like this one here. Find the product. 2x plus 1 times 3x squared minus x plus 4. We can draw a table like this, where the first term is here, and the second term is here. And then we can then add this up. We get 6x cubed plus x squared, and then plus 7x plus 4. And that will be the result to this question. Next, we can also use FOIL to multiply binomials. A shortcut called FOIL is sometimes used to find the product of two binomials. This is called FOIL because we multiply the first term, the outer term, the inner term, and then the last term of each binomial. Here's the first term, ax times cx squared, which will ax times cx, and then we get acx squared, and then the outer terms here, ax times d, so adx, and then the inner terms b times cx, we get bcx, and then plus that the last term, so just b times d, so bd. The FOIL method arises out of the distributive property. We are simply multiplying each term of the first binomial by each term of the second binomial, and then combining like terms. Also, we have to learn this. It's important. So this is called perfect square trinomial. So certain binomial products have special forms. When a binomial is squared, the result is called the perfect square trinomial. We can find the square by multiplying the binomial by itself. However, there is a special form that each of these perfect square trinomials takes. And memorizing the form makes squaring binomials much easier and faster. Let's look at a few perfect square trinomials to familiarize ourselves with the form. So here we got x plus 5 squared. So when we multiply that out, we will get x squared plus 10x plus 25. And for the second one, we get x squared minus 6x plus 9. And the last one, we get 16x squared minus 8x plus 1. So notice that the first term of each trinomial is the square of the first term of the binomial. And similarly, the last term of each trinomial is the square of the last term of the binomial. The middle term is just double the product of the two terms. Lastly, we see the first sign of the trinomial is the same sign as its binomial. So when a binomial is squared, the result is the first term squared added to double the product of both terms and the last term squared, like this. X squared plus 2ax plus a squared. And the next method we got is difference of square. Another special product is called the difference of squares, which occurs when we multiply a binomial by another binomial with the same terms but the opposite sign. Let's see what happens when we multiply x plus 1 with x minus 1 using the FOIL method. We will get x squared minus x plus x minus 1, which is just x squared minus 1. The middle term drops out, resulting in the difference of squares. Just as we did with the perfect squares, let's look at a few more examples. X plus 5 times x minus 5. We get x squared minus 25. X plus 11 times x minus 11. We get x squared minus 121. And then the last one is 2x plus 3 times 2x minus 3. We get 4x squared minus 9. Because the sign changes in the second binomial, the outer and inner terms cancel each other out, and then we are left only with the square of the first term minus the square of the last term. So the next method we got is performing operations with performing operations with polynomials of several variables. We have looked at polynomials containing only one variable so far. But a polynomial can contain several variables. All of the same rules apply when working with polynomials containing several variables. Consider an example. A plus AB times A times 4A minus B minus C. So use the distributive property, we get A times 4A minus B times C, minus C, and then plus 2B times 4A minus B minus C. And when we multiply that out, we will get 4A squared minus AB minus AC plus 8AB minus 2B squared and minus 2BC. And we can add these up since they are like terms. So 4A squared plus negative AB plus 8AB, so it's 7AB, and then minus AC minus 2b squared, and also minus 2bc. And here's the result. We got 4a squared plus 7ab minus ac minus 2bc and minus 2b squared. So let's do some practice question. Identify the degree and leading coefficient of a polynomial. For the following polynomials, identify the degree, the leading term, and also the leading coefficient. I'll give you guys 40 seconds to work on these starting from now. Alright, so it's actually pretty simple. The first one, the degree is just 3, since it's like highest power of x is the third power, so the degree is 3. And then the leading term is a term containing that degree, which is just this negative 4 times x cubed. And the leading coefficient is just the thing in the front, so just negative 4. For the second one, the highest power of t is 5, so its degree, the degree is 5. And the leading term is the term containing that, so it's 5t to the power of 5. And then the coefficient is just 5. For the last one, the highest power of p is 3, so the degree is 3, and the leading term is also this one, so just negative p cubed, and the leading coefficient is the thing in front of it. It's just negative 1, although it didn't say a 1 here, but we know that it's 1, so negative 1 is the leading coefficient. Alright, practice question number 2. Adding polynomials. So find the sum of these polynomials. So I'll give you guys like 20 seconds to work on these starting from now. Alright, so the answer for this is actually pretty simple too. So we got 4x cubed for the x to the power of 3 term, and then we got 12x cubed plus 8x cubed, since they're like terms, so we get 20x cubed, and then we got 9x minus 5x, so 4x, and then the last one is just negative 21 plus 20, which is just negative 1. Alright, so practice question number 3. Find the product. I'll give you guys again 30 seconds to work on these starting from now. Alright, so the answer for this one, it's x to the power, that's 3x to the power of 4 for the first one, and then we multiply that out, we get 12x cubed for 12x cubed, and then also for this one we get 2x cubed, so total negative 12x cubed, and then plus 2x cubed, so we get negative x cubed. And then for the x squared terms, we get 21x, and also for this one we get negative 8x squared. So when we subtract 21 with 8, we get 13, so 13x squared. And then for the last two we get 21x, since this 3x times 7 is 21. And then for the last term, with no x, we could just got 14. So the result is 3x to the power of 4 minus 10x cubed plus 13x squared plus 21x and then plus 14. Practice question number 4. Expanding perfect squares. So go on and expand 3x minus 8 squared. I'll give you guys 20 seconds to work on this, starting from now. Alright, so the answer is pretty simple as well. So we can begin by squaring the first term and the last term. Since it's negative in the middle, so we know that it will soon cancel out. So we can just do the square of the first term, so 9x squared, and then for the second term, so it's just 64. What am I saying? So yeah, that's the result. And for the last question, multiplying polynomials containing several variables. So multiply this equation, not equation. So it's just polynomials. So x plus 4 times 3x minus 2y plus 5. I'll give you guys 50 seconds to work on this since it's harder. So starting from now. So the answer for this one, we get x, like we can distribute this using the distributive property. So we get x times 3x minus 2y plus 5, and then plus 4 times 3x minus 2y plus 5. And then we multiply that out, we get 3x cubed squared minus 2xy plus 5x plus 12x minus 8y plus 20. And we can combine the like terms, which is 5x and 12x, so we get 3x squared minus 2xy plus 70x minus 8y, and then plus 20. Yeah. And that's all for today. Thank you for listening.